Hi, everyone, and welcome to today's online talk on how to achieve sub-second analytics on Apache Kafka with Confluent and Imply. My name is Mauricio Barra, and I'm part of the product marketing team at Confluent. And I am very excited to be joined by our speakers today, Rachel Pedresky and Josh Treichel. Welcome, guys.
Thanks, Mo.
Good morning.
Awesome. So basically, I'm gonna move to the next slide. I'm gonna walk you through a little bit of introductions and some logistics about today's session, right? So let's start with Rachel. Rachel is the Field Engineering Director at Imply Data. She's a widely certified database administrator with more than 20 years of experience, and she's been working on all kinds of technologies such as Apache, Cassandra, Ignite, and Druid. So we're very, very happy to have her join us in this panel. And then also Josh, he's Partner Solutions Architect at Confluent. And him as a software engineer, Josh has actually spent over 10 years building and integrating complex systems. And he also previously worked on the Confluent team for customer operations. So he has a lot of experience also supporting some of the largest Kafka deployments in the world. So in today's talk, Rachel and Josh will share with us, we'll discuss how KSQL, which is the streaming SQL engine for Apache Kafka developed by Confluent, can help you transform and filter streams of data so you can ingest them into Imply's scalable analytic engine. Right, and with the purpose of gaining real-time insights with the modern user interface of Imply. So this session will be about 60 minutes long, and we'll spend the last 10 to 15 minutes doing some Q&A. So please go ahead and submit your questions using the GoToWebinar panel at any point in time throughout the presentation, and then we'll gather those questions and we'll pass them to Josh and to Rachel at the end for them to answer. Also, a reminder that this session will be recorded and that we will send you the slides and the recording in an email right after the talk. And so with that, I'll just basically hand it off to Josh. So thanks, Josh.
Thank you, Mal. So before we start the presentation, we'd like to keep this a bit well, at least slightly interactive. So Rachel created, if you could all go to this URL and help us in our demo in the end. Rachel, I don't know if you want to say a few words about what this will do.
Sure, this is actually going to take you to a website called Koalas to the Max. And it's a fun website. Play around with it just in case you need something to do while you're listening to our presentation this morning.
Cool. All right, so for those of you that don't know Confluent, we were founded by the creators of Apache Kafka. Project came out of LinkedIn and was created to solve the problem of managing massive amounts of data flowing throughout the organization and making that data easily accessible and consumable by any part of the organization that was interested. So we're still by far the largest contributor and tester of Apache Kafka. And Kafka was really created to deal with this new world of data. So there are several big trends in the way applications are being deployed that are at the center of these changes. So we now have mobile applications, multiple clouds, microservices architectures, IoT is everywhere, and everybody wants to throw a little AI and machine learning on it. And so these trends are driving change in the way data flows across organizations. So today the data experiences massive volumes of new data generated daily. It's distributed across applications, devices, data centers, and clouds, and it's structured, unstructured, and oftentimes both in the same sense. And we have many existing systems for handling this data flow, but these legacy data integrations tend to have architectural flaws which don't allow them to meet today's needs. So if you take message-oriented middleware, for example, it has limited to no data persistence or single point of failure. ETL is primarily used for databases. It's batch-oriented, not super scalable. and ESBs, enterprise service buses, are typically fragile, point-to-point, and have weak transformational capabilities. So these tools really just weren't built to handle the scale and type of data that we're seeing today. And architectures have been changing to keep up with this new type of data. So we're seeing massively scalable databases, analytics tools like Imply, but we still need to change how we manage data flowing through the business. And so that's where a streaming platform comes in. So a streaming platform sits at the center of the organization. It allows for applications, databases, analytics tools, and other systems to be decoupled from one another, but still communicate and share data through a single source of truth, in this case, the streaming platform. And we see Kafka as the base for the stream platform. It has a few key differentiators that we consider requirements for a streaming platform, and the first being scalability. So Kafka is a distributed system. So it's built to be highly available, horizontally scalable, and it can meet the demands of any organization. So we have some of the largest companies in the world that run their business on Kafka. The second piece is storage. So Kafka has true storage. Kafka writes to disk, replicates that data across servers so that you know when your data is written to Kafka, it's going to be there as long as you need it. Finally, a streaming platform needs stream processing. It's in the name. It's got to be there. So with Kafka Streams, you can build streaming applications, perform ETL functions, all in real time, all tightly integrated with Kafka. And so I said next generation, but really this system is already kind of here. So 35% of the Fortune 500 already use Kafka. And as you can see here, a majority of the top companies in their industry rely on Kafka. So Confluent, we built an enterprise streaming platform on top of Apache Kafka to make it easy for companies to get value out of Kafka and focus on building business applications with that data rather than focusing on the infrastructure to move that data. Not going to go into too much detail here, but I do want to highlight some key areas of the Confluent platform. So right at the bottom in the blue, we package just vanilla Apache Kafka. We don't have our own version, so don't have to worry about Confluent's Apache Kafka. That doesn't exist. It's just Apache Kafka. And so on top of Kafka, we provide Confluent open source. This is Apache 2 licensed, just like Kafka, but it's owned by Confluent, not the Apache Foundation. In this, we have some incredibly valuable pieces. So we have a schema registry, which allows you to manage the type and format of data and topics. We have a REST proxy, which allows you to produce and consume data over HTTP. And we have KSQL, which I'll go into just after this. It's basically just an awesome way to do stream processing. And then we have a number of connectors and clients to make it easy to connect to these third-party systems or write integrations in non-JVM languages. On top of Confluent open source, we provide Confluent Enterprise, which is really all about operationalizing the platform for production. So we have a control center to manage and monitor things. We have Replicator for disaster recovery and globally distributed companies. I can talk. We have an MQTT proxy for easily integrating IoT devices. And coming out shortly, which we're super excited about, is our Kubernetes operator. So this will make it easy to deploy and manage your clusters either in your private cloud or on-prem, and it'll be very similar to a cloud in like Confluent Cloud. And so if you don't want to do any of that, we have a fully managed service for those of you that want Confluent, but you don't want to manage it yourself. So I did want to dig in a little bit to KSQL. So I mentioned KSQL is awesome, and it is. KSQL is a really easy way for non-developers to get access to the world of stream processing. So it's just a layer that sits on top of K-streams. So under the covers, you are running K-streams, but with the ease of the SQL-like syntax. And if you're comfortable with SQL, you can get comfortable with KSQL in just a few minutes. You can run KSQL through our enterprise control center. We have a command line interface. You can submit queries via REST, and it's great for streaming ETL, anomaly detection, event monitoring. Just it's very straightforward to use and pretty powerful. And so let's take a look at a simple example of KSQL that's combining a table and a stream, which is something that's really common to do. So if we start from the from statement, so here we're working with clickstream data. So each stream is really just a topic with metadata associated with it. So this clickstream data is flowing through a topic, and then we apply a schema to it so that we can work with it in KSQL. So in this case, we're going to do a left join on the clickstream data to a web users table. So tables are different from streams in that a table just has the latest version of a record. So it's much like a compacted topic in Kafka, or how you would traditionally think about a table in a database. So here's the clickstream data is flowing through in real time. We join it to this web users table, which has the latest up-to-date information on our users. And we create a joined information from the users table. So now this output stream, which we're calling enrich stream, is now available for anyone to consume who's interested in the combined streams. So I'll show a bit more in our demo. But once we have these easily consumable streams, we need tools to be able to handle the type and quantity of data that we've been discussing with you guys. And so that's where something like Imply comes in. So I'm going to pass it over to Rachel, and she can take it from here.
Okay, so let's first start off about a little bit about Imply. So Imply was founded by the creators of Apache Druid. Apache Druid is currently incubating in the ASF and the D3 framework. It was developed at MetaMarkets, and we are currently the largest contributor and tester of Apache Druid. So we're going to go back in time a little bit before the idea of streams were a glimmer in JCrep's eyes. So this is back in the 80s, the world of mullets and large bangs, when somebody had a relational database out there that was taking in data and saying, right, maybe we should do something with this data. And at that point, data warehousing was born. Operational databases were not designed for doing the types of analytic queries that people needed at the time. So what was developed was data warehousing. Ralph Kimball and Bill Inman both created strategies on how to take data that is in a relational database or in a transactional system and put it into a system that's better for queries. Because of relational databases at the time, it was very expensive to store data, and users wanted data that was very clean and very easy to access. So what started out was a concept called schema on read, or schema on write. So as the data was flowing through our sources, it was written into a star or snowflake schema, and then being able to be served out either through an OLAP server or through front-end tools by the end users. This schema on write, it's called ETL, and it would take traditionally about 18 to 24 months for that ETL process to be written, to create the data in a clean format for people. And I mean, this was great for a long time, but the world changes too fast, and 18 to 24 months was just way too long for to get your answers for your databases. So a new technology came out in 2011 and to make this a lot easier. And this was the Hadoop set of tools that I think a lot of you are familiar with. And it allowed us to create an architecture called data lakes. And in data lakes, you are going to be storing all of your data. You might be taking data from a data warehouse or your operational databases, but it's all data and all types for all users. And instead of taking the time to do the ETL up front and do schema on write, what happens is all the data gets put into a lake for cheap storage and for easy access by the end users. And the schema is now done on read. So the front end tools out there for the end users doing AI or machine learning are all going to have to cleanse the data as it's coming out of the data lake. And this has worked fine, and the combination of both strategies is used in a lot of places. But this was all before the idea of streaming data. So where does your streaming data go? And to use the concepts of a data lake, it's supposed to go in a data lake. But data lakes are designed for batch processing. So these new world of you need to have batch processing at the same time as your real-time streaming data creates a need for a new type of architecture. I like to call this new type of architecture a data river, but the idea is that it's flowing in from your streams at the same time that it's that needs to be enriched or added to your lake, or just even queried on at the same time. And Hadoop's mascot is not a jackrabbit. It's not designed to be fast. It's not designed to be real time. So how do we deal with this? How do we bend and twist our systems in order to be able to handle this real-time data that's coming in from Kafka? And so if you think that this is a kind of a pie in the sky or a future-looking system, it's not. This is user data. This is application data. This is machine data. And in order to enable types of applications like digital marketing or supply chain user experience, network performance, everything that requires you to be able to query on data in the real time, maybe store it for long-term storage, so maybe a couple of years to look at trends over time, and then also enrich it from data that might be coming in from your data warehouse or your database. And this is why Druid was developed. So about 5 years ago, a company called MetaMarkets is dealing with ad tech data. And ad tech data definitely falls into this category of very real-time data that's coming in fast, a lot of it, and that they need to be made decisions very quickly in order to change what ads being shown or make decisions in real time. But at the same time, the advertisers want to see the type of spend and they want to be able to do analytics on it. So it needs to be tracked with existing data. So the developers that tasked with this looked at the existing tools that were on the market. So they looked at search platforms like Elasticsearch, and they said that this was great because it had real-time ingestion, so it solved the data lake problem of real-time ingestion. And the schema was flexible, but there was no ability to slice and dice the data. There was no analytics, there was no SQL, and the tools and the end user tools out there for it were limited. So then they looked at OLAP tools, so the traditional data warehouses out there, or the data lake technologies. And these were great for batch ingestion, and they stored things fairly efficiently, but you had no real-time data. They also looked at some time series databases that were out there, and they liked some of the theories around the time series systems, but there was nothing that took the best of both worlds. So they created a new product called Druid. So Imply is the only end-to-end solution for streaming analytics built on Apache Druid. And in the 20 years or so that I've been implementing data warehouses for people, it's always the same problem. You go in and talk to somebody about a database and you get the data people really excited about different types of indexes or new join strategies. But then you have your end users, and your end users still need their questions answered, and they still need their questions answered fast. And so in the old worlds of data warehouses and data lakes, I would be cobbling together solutions from bits and pieces. I would say, all right, well, we need a little bit of this and a little bit of that. So your end users are going to use these tools, and your backend database is going to be this database to solve this problem, and you're going to use these ETL tools. And there was never a single platform that managed everything for them. And especially, so Imply has been designed to do an end-to-end system based on Druid. Druid is a highly scalable solution. We have implementations that are in thousands of nodes and petabytes of data. Distributed systems are complex. ETL is complex, and visualization is complex. And Imply will provide you a solution for all of those in a single product. So it allows you as a one-stop shop for all your user data, your application data, your machine data, to be able to enable a number of these different use cases. And don't take it from me, take it from our customers. So these are the people out there that are currently using Imply to solve these, I like to say, data river style problems, where you have data coming in real time. You want to be able to build up storage and enrich it from data from other sources, and then be able to provide your users an easy to use exploratory interface. So Josh, I'm going to hand it over to you to talk a little bit about what we're going to show everybody about how the stuff works together.
Effectively, what I talked about in the KSQL query, we're just going to show it live, and hopefully the things work because we all like live demos. So we have clickstream data running right now. I have a clickstream data generator running, sending data to a topic, and then I'm going to run some KSQL on top of it, show you how to do joins, and just show you how to inspect the data in KSQL. And then Rachel's going to pick up that data and show how easy it is to integrate Imply or Druid to Kafka, and then show the awesome stuff you can do in Imply. All right, so hopefully you can see my terminal. So just want to kind of show off KSQL for those of you that haven't seen it. Very similar to just ordinary SQL. So I'm on the command line interface right now. Like I said, we have a tight integration with Control Center too. So if you have Control Center, you can run these from Control Center. You can see your persisted queries. You can see your streams and your tables and stuff like that. So it's pretty cool. But let's see. Let's just check out our streams. So these are the streams of data I currently have running. You can see that each stream is backed by a topic, and each stream has a format. So just like a database, I can inspect these a bit more. So I can run a describe. So I want to see a little bit more about that clickstream stream. So now I can see that there are fields associated with this. I can see that there are types associated with this. And so now I can imagine running queries against this because I know the type of data that it's in it. So let's just run a select from clickstream. And so here's where it gets different. So this is live data. I'm going to stop it. That's live data running from, running to the clickstream stream. And so unlike a database where I'm running a select star, I get all the rows back in that table. This never ends because there is no end unless you stop sending data in, but then it'll just continually poll. You have to actually terminate the query for it to stop. So that's the main difference when you're dealing with KSQL versus traditional databases. You have to understand that streams never end. And so thinking about that in a different way is kind of a change of mindset. And so now I did a select star, but just like a traditional database, I can, I know there's an IP on this clickstream, so I can do a select IP. I can do a select IP limit 10. And so it's really easy to get a feel for it, really easy to start playing around with the data. So I think we all understand that. So those are streams. So now if I wanted to take a look at the tables. And again, so tables are different than streams, where streams is just live data flowing through the system. A table is the latest record and the most up-to-date record. So right here we have a web users table, which is backed by a Kafka topic called clickstream users. So we can imagine this clickstream users topic is continually updated as user information is updated. And the web users table will only keep the latest version of that user. So if we want to do a describe web users, we can see again, there are fields associated with it, and those have types. The one thing to note here is that on my web users table, I have a user ID. On my clickstream stream, I have a user ID. And so now I have the ability to join these two things because I have a common key, right? So just so I don't ruin it while I type, I'm gonna go back in memory, but you can see here in my history, I'm selecting a few fields. This is down at the bottom, user ID, status, request, IP from the clickstream table, and then I'm just gonna select one field just to show it off. I'm gonna select city from the users table. I can do that left join so that I still get data back if there's nothing in the users table, and I'm doing the left join on user ID. So I can run this, and again, this will go on forever because as data keeps flowing into clickstream, it'll just do a live join to the users table and then get a combined stream. So right now I'm just playing around with it. Nobody could consume this stream I've created. But if I wanted to, I could say create stream enriched click, if I could type, typing's hard, as. And so now what I'm doing is I'm creating a persistent stream. So this persistent stream enriched click stream has this backing query, and this is going to run. And now what's cool is anybody that has access can hook in and get this enriched clickstream data, so they don't have to do this join themselves, or they don't have to imagine that's a filter, or imagine a number of different things, like I updated one of these fields, or the possibilities are kind of endless, right? And so now this stream is created, it's running in the background. Anybody that's interested in that data can hook up to it. And so just wanted to show off how easy that is. And so now you can imagine I have this new stream of data running, but where does it go, right? So somebody has to want to show that data, visualize the data, run analytics on that data, and that's kind of where Imply would come in. So they would let's show off how easy it is to integrate this Kafka cluster to Imply. Throw it to you, Rachel.
Awesome. Thank you very much. And let me go ahead. Can you pass me over? There we go. Perfect. So Josh just created us a stream of data, and that stream of data is actually coming in from this website, which we sent you to earlier in the presentation, called Koalas to the Max. And if you guys were playing with it, which I think that some of you were, you'll find as you mouse over the image, it starts to show up, it pops the bubbles. So what we've done is actually added the clickstream information. So as you were all doing all this information, you were creating Kafka data and creating a Kafka stream for me to show off. So let's see how this goes, since live demos are always a lot of fun. So let's start with taking the data. So this is the Imply UI. It is a web-based interface that is running off of a underlying Druid data source. So the first thing that I'm going to do is I'm going to pick up the data that Josh has given me. We can choose a number of different data types, but Kafka being the important one here. And I can go ahead and put in the Kafka topics that Josh has set up for me. So keep in mind here that I don't necessarily need to know anything about Kafka. I just need to know what the brokers are and what the topic name is, and I'm given all the different columns that were available to me on this stream. So you saw Josh creating a new stream with KSQL to enrich the data. Then I'm picking it up directly from the Imply UI. I don't need to know a lot about Kafka. I can say, yes, this is the data that I want. And now I can configure it. So Druid requires a time column. As I mentioned, it does borrow some of its features from time series databases. And then it will ask you if you want to roll data up. And this is a feature of Druid that allows for data to be compressed as it's being loaded in. So however you want, if you want to roll up data and only see it at the second level or at the minute level, you can tell Druid at this point to roll it up, and it will compress it. Druid is a columnar-based database, so the actual compressions of each column is already very high. So we usually see a 10-to-1 to a 50-to-1 compression, based on the roll-up and based on the fact that it's a columnar system. Once I have the columns, I can change configurations to it. I can view them. I can do some more transforms if I'd like to it, and I can create a data set. Notice there's a box here to create a data cube. So this will become immediately available for analytics. I'm going to review the config, and I'm going to start loading data. So this is connecting to the topic clickstream, and it's going to start building out a data set for us. So as we started the webinar, we asked you all to go to that website, and we're going to take a look at that data set right now. So we are looking at the previous hour's worth of data, And we can see that we've got 19,000 events in the last hour. On the left-hand side, I have all the dimensions that were available in that Kafka topic that Josh gave me. And Drew had figured out which was dimensions and what was measures. So I didn't have to make any sort of specific changes to that, though you can. This is completely configurable. And even within the app itself, you can edit dimensions and add dimensions as you need to. So one of the features is the loaded image, and the loaded image that we grabbed is this one here. So I think we should find it. Looking at the previous hour. There it is. So we can go ahead and select that particular image and take a look at the event types associated with it. So we've had 2 good loads. Actually, let's do the previous day on that. There we go. A little bit more data. So we've had overall 55 events. We've had the number of percentage clears 38, layers clears 11. If we want to see a little bit more about we can look at the event subtype, and it will automatically break down the each of the individual pieces. So if I wanted to just look at a particular event, we can sort by the number of events and give it a limit directly in the UI. Now I might want to see how many people from different regions. So we're going to use some of that geography information to see where our users are coming from. So it looks like you all come from the United States. We can drag down and see everybody's from California. And is everybody from an individual city? Looks like most people, we don't know where their city is from, but we've got 15 people from Santa Rosa. So it's good to know that we have a lot of Santa Rosa people on our webinar this morning. So there's a number of other visualizations that you'll be able to see within the Imply UI: tables, line charts, sunbursts, heat map, geography, various tree maps. And looking at our various loaded images, if we wanted to see a little bit higher data set, we could go ahead and select that particular data set and look at the user sessions, for example, associated with that. So a number of slice and dice abilities here within the Imply UI. So that's what I had to show now. Do we want to open it up for questions?
So basically, let me just go into the questions that I collected from our audience, right? So the first one is, I think it's a little bit for you, Josh, as you started the presentation, and you kind of presented different spaces around where we have the streaming platform, and which includes KSQL capabilities. One of the questions was around Spark. There's one of the person in the audience that says Spark also allows stream processing. So what makes Kafka stand apart or different from what you can do with Spark from a stream processing standpoint?
Sure, cool. Yeah, so there's a number of, I mean, the great part about Kafka is that it is kind of open ecosystem, right? So if you have a Spark cluster, you can absolutely use that against Kafka, Flink, etc. We find that for new use cases, when especially when people are putting in a Kafka cluster or they're picking up a new use case, we like them, let's try to solve this with KSQL because it's, the overhead's not there, the integration is tight, and you're writing queries instead of programming. Oftentimes though, like it's Spark versus like K-streams, right? And so K-streams is a bit different. So K-streams is a library that you run in your application. And so instead of having its own cluster, it's running in your application and it's working with the Kafka cluster. So it's quite a bit different. There's no separate cluster to manage. So the overhead's quite a bit lower. The integration's quite a bit tighter. So you're not moving your data from a Kafka cluster to a Spark cluster back to a Kafka cluster typically. So any use case that goes Kafka to Kafka, I think is a great choice for K-streams, KSQL. If you're going like Kafka somewhere else, like Kafka Spark somewhere else, or if you already have it implemented, oftentimes Yeah, that's great too. I will say that KStreams does auto scaling really well. So add another application with the same group, and it'll scale up. Versus Spark clusters, sometimes you start the job, you realize you need more resources, and then you have to stop it, add the resources, start it again. So I think there's use cases for both. I think typically the tight integration, we see people just trying out KStreams and KSQL to see if it works for them, and if it doesn't, then they fall back on what they might know, which is Spark or Flink or something.
Awesome, thank you. So the next question was also, as you started presenting about KSQL, somebody had a question around, can KSQL query Kafka topics instead of a stream?
Yeah, so really, basically a stream is just metadata on top of a topic. And so you can't directly query, like I'm not presenting right now, but if I have a topic that I've never run a create stream statement against, I can't run KSQL against it. KSQL doesn't know about that topic. But if I run a create stream blah against topic blah, it'll just like save metadata associated with the blah topic so that KSQL knows how it's set up, what fields are available, and so then when it queries it, it knows how to use it. So yeah, I mean, I guess kind of like you can query topics, but you do need to quote unquote set them up first.
Perfect. Okay, so the next question is actually, I think, for Rachel. Rachel, the question is, how does Druid override the older data segments if the time interval overlaps?
So a Druid is designed to it's designed to write mostly, and any updates to the data are designed to be re-indexed as older data comes in. So if you are bringing in older data, it will just re-indexes that as it comes in. There are different ways, there's different strategies to deal with updates, and my email address is available at the end of the webinar, and we can talk a little bit more over email about strategies on how to deal with late data and other strategies for updating data rather than having it overwrite if that doesn't work for you.
Perfect. Okay, so next question. The next question is also, I think, for you, Rachel. So the question is, can Imply automatically pick up the column from Kafka topic with the nest Avro schema?
It does, yes. That is so you saw through the UI that I put in the different topics and the brokers, and it went through and it looked at all the columns. If new columns start being added to that Kafka broker later on, it will automatically pick those up and add those to the underlying Druid table. And this is configurable. You can actually change your ingestion spec, which is what controls these ingestions, to either allow this or not allow this, depending on what your use case supports.
Okay. So next question is, can Imply use sources other than Kafka? And can it merge data from those multiple sources?
So yes, it definitely supports other data sources besides Kafka. Kafka is Kafka is special because it does have a native Kafka indexer, but it also imports data natively from Hadoop formats. So ORC and Avro, any type of JSON formats that you have. So pretty much, and Kinesis, as well as any other streaming technologies through what we call Tranquility. Can it merge the two? So what we typically recommend is either that be done at ingest time, so either through a streaming or ETL process, or if that data does need to be queried separately and only once in a while queried together, Druid is very, very good at union style queries. So again, depending on what your use case and what your queries require, either you will do the ETL and the merge of two different data sources at ingest, or you'll do it at query time. So a little bit of schema on write and a little bit of schema on read.
Okay, awesome, thank you. I think I have a question also here for Josh. The question was, does KSQL run as its own cluster or as part of the Kafka brokers?
Yeah, so unlike KStreams, which runs against the Kafka cluster, KSQL does run as its own cluster. So that's where the state's stored. That's where the query, like how to run the query, is figured out. So yeah, it's a cluster that runs alongside the brokers.
Awesome, and I think related, I mean, to KSQL question also is, can I use KSQL with Avro data?
Yep, yeah, you can use KSQL with Avro data, JSON data, and CSV, so comma separated values.
Awesome. Thank you, guys. I have another question. This one is going to be for Rachel, I think. So the question is, how about high cardinality data in Druid, which tends to be a problem with other real-time time series databases?
That's a great question. And the underlying problem of high cardinality data within Druid is for rollups. So if you have a high cardinality column, then you're not going to get the type of rollup that might compress the data to what you want. So if that's okay with you and you don't mind not having the compression, then you're okay. But we also provide sketches. And you can define a high cardinality question as a sketch, and that will allow for rollups. You can actually so you can do select. You can actually do select count stars, and you can count distinct on those sketches as well. It just might take a little bit more time, but it does give you the flexibility.
Awesome. So I think I have an interesting question similar to the first one that I posted on Josh about the comparison of Spark versus KSQL. There's a question around basically how does Druid compare or differ from Cassandra? Can you touch on that one?
I can actually. I spent 4 years as a Cassandra consultant, so I think I can pretty confidently answer this. So Cassandra is very well suited for what we would call OLTP style data sets, so transactional style queries. So Cassandra is designed for very small writes, lots and lots of small writes, and lots of small reads. And you need to know exactly what your query is going to look like in Cassandra in order to model it correctly. Cassandra can't do table scans. It reads only a single partition at a time, and it reads very quickly within that partition. But if you are moving outside of that partition in any way, you're going to struggle. Druid, on the other hand, is an OLAP system. It is designed for table scanning. It's designed for crunching through a lot of data. So it writes very quickly and it reads very quickly, but it reads in a very flexible way where you can have anything on the where clause, whereas Cassandra that you cannot. They're both very, very powerful databases. They're both distributed, highly available. Cassandra can do multi-data center replication and provide sort of an always-on type of backbone for an application, whereas Druid will be your high-speed, real-time analytics style platform. So 2 very different use cases, 2 very powerful systems.
Thank you. So question for Josh now. Does KSQL use the schema registry to work out how data migrates over time from, say, like a version 1 JSON to a version 2 JSON? Or how do you see schema registry playing a role within KSQL?
Yeah, cool. So so currently schema registry only works with Avro. There's talks of we have a lot of people that are interested in working for like JSON or protobuf, but currently only works for Avro. And yeah, so the schema registry and KSQL are tightly integrated when you have Avro data, and then schemas can evolve over time. So it doesn't quite work that way for JSON. You have to handle that more manually.
Perfect. Okay. Another question. We have a good amount of questions, guys. So very interesting topic for our folks here. So how does Druid collect location information? Does it rely on third-party source like Google Analytics?
So Druid does not it Druid is a database. So it's going to take whatever data you give it. So if you need data that's in that's geography information, it's going to get it from your stream. So the visualizations of Imply on top of that, do require that your data is set up in a certain way in order to be able to visualize maps and geographies. But in terms of actually getting data from someplace else, Druid adjusts data from your data source.
Okay. Perfect. I'm just sorting here through the questions. So question might be for you, Josh. Is there a segment compaction for Kafka indexing services? I don't know.
So compaction in Kafka probably works. Well, for those of you who don't know, there's kind of two ways topics are cleaned up. You can set them to delete. So after you hit a size limit or you hit a length of time, the data in the topic is deleted at the end. And so that's one thing. One way you can set up topics. The other way is you can set the topic to be compacted. And so a compacted topic works much like a table, where a thread runs behind the scenes and kicks out everything but the latest key. So in that case, you actually have to have a key. But it'll, that's great for like, if you had a topic of users, just like a table. So this is kind of outside of KSQL, but you could keep a compacted topic where you're effectively storing the data infinitely. You're just storing the latest version of that data in the topic. And so I think sometimes people ask, do I need a topic to be compacted for it to be a KSQL table? And the answer is no, but you might as well have it be compacted, so that way you're not storing a bunch of data that's unused, right? So they don't need to be hand in hand, but they're useful. If you have a lot of data flowing, you might as well compact the topic. Hopefully that answered it.
Okay, thank you. Next question, I think this one's for you, Rachel. Can we add more than one column as timestamps?
That's a great question. So you do give Druid a single column as a timestamp, or it will actually create its own. And if you need to have that two or more columns to be used as a timestamp, there's ways of manipulating that at ingest time.
Okay. This one is a little bit of a combined question for both of you. So the question is, can you discuss using Imply with Druid and Confluent with Kafka with PCI data and PCI DSS, particularly with the managed services?
Josh, you want to start that off with the Confluent managed service?
What's that? Sorry, I was on mute.
Yeah,
I was just going to say.
So I'm going to repeat the question, right? Because I think it's a little bit of a combined question for both. The question is if we can discuss using both, Druid and Kafka with PCI data and PCI DSS.
Sure, I can take our portion, although I'm not a security expert, and I probably so I might screw this up. But so our Confluent Cloud is just released. We're in Amazon, GCP, Microsoft Azure this year, and so we don't have all we don't have all the compliances kind of checked off. I know we're SOC 2 compliant. I know we're working on the other ones. I don't know if, like, from a compliance standpoint, how that would work with PCI data. But oftentimes if you encrypt the data on your end, then it's okay to be sent to Confluent Cloud, and we're not beholden to anything. But yeah, like I guess I would probably kick that one. Whoever had that question, feel free to reach out over email, and I can talk to our security team about it. Rachel, I don't know if you know the answer from a Imply managed service standpoint.
Well, yeah. So our managed service runs in. It's currently only AWS, and it runs in your VPC. So you have complete control over what data you have complete control over your data. As far as PCI compliant applications, we do have clients that have built PCI compliant applications using Imply. And we also have a number of GDPR enhancements to the product through the Imply front end. But again, any sort of specific questions on how that works is probably best to be taken offline.
Awesome. Thank you, guys. So I think we have time for a couple more questions, and then we'll be at the top of the hour. So a couple more, one for each one of you. So for Josh, there's a question. So it says, for KSQL, can you talk about the ways to access the KSQL queries? You mentioned the control center, but are there other ways to basically operate that aspect?
Yeah, so how to run queries in KSQL? Yeah. So Control Center has a nice integration. So Confluent wrote KSQL, we wrote Control Center. So we have a UI, like a GUI, where you can see your streams, you can see your persistent queries. But you don't need Control Center. So KSQL is open source. And so you can download it, run it. You don't need a license or anything like that. And then you can either, when you do it that way, you can do it like I did through the command line interface, or you could submit queries via REST. So those are kind of the two ways that people do it if they don't have Control Center. Or even if they do have Control Center, oftentimes, certain users like CLIs and certain users like GUIs.
Great. And Rachel, last question for you. Does Imply run best on dedicated hardware, or can it be containerized without much issue?
It is commonly containerized, and we run very well in the various different clouds. So both work fine. Does not need dedicated hardware.
Great. So thank you, guys. I think it's time for us to wrap up. But great answers to a lot of questions. So there was a lot of interest from the folks that joined us in this webinar. And so thanks, Rachel, and thanks, Josh, for joining us. Great content.
Cool.
And for everybody listening, the recording will be made available online, and we'll send it to you in a follow-up email. For more online talks hosted by Confluent, please be sure to visit us at confluent.io online talks. Thanks for joining us, and we'll see you next time.